The reason for that background is our next piece of material is a very high-level introduction to Rails, which is exactly a model view controller framework. And I'm going to call this From Zero to CRUD, because we're going to start from no knowledge at all about Rails and try to relatively quickly, maybe not by the end of today, but certainly by Tuesday, to get to understanding how Rails handles the 4 basic operations on a resource that we first started learning about. So remember that the framing of the course was, think about your app as a set of resources and operations done on those resources. The 4 basic operations of which are create, read, update, delete. Because that pattern of apps as resources is so prevalent as a way of thinking about how your app functions, and because the model view controller division of responsibilities is such a powerful organizing principle for SaaS apps, Rails basically combines those 2 things. It says, I'm going to make it super easy for you to build apps that are structured as model view controller, and in particular, apps that really are about collections of resources and operations done on those resources. Rails is very opinionated about how it wants you to do those things. If you make yourself agree with its opinions, your life will be a joy and a breeze. If you find yourself trying to go against its opinions, your life can sometimes get a little bit messy. That is not to say that its opinions are the best opinions 100% of the time, but there's something to be said for a framework that basically takes a point of view and says, if you do things this way, life will be easy. And usually those choices were not arbitrarily made by the framework's designer. They're usually the result of experience with previous versions of the framework, with previous apps not using any framework, and somebody saying, gosh, wouldn't it be better if the framework could sort of handle this commonality for me, and then I wouldn't have to write it every time anew for every new app. So if you find yourself using a framework and you're trying to sort of shoehorn what you're doing, and the framework doesn't seem to be cooperating, you can ask yourself 2 questions. One question is there something that I don't quite understand about why the framework is designed the way it is? And if I understood that better, would my code seem like I can organize it in a way that matches better what the framework wants me to do? And if you've done that, and the answer is still that you can't make it fit, you might ask yourself whether the framework is actually a good fit for the thing you are trying to do. As I said, model view controller is a great way to organize certain kinds of apps, but if your app doesn't really lend itself to that because it isn't an app whose workflow fits that pattern, then using Rails is probably going to be painful. It will expect you to do things you don't really need to do, and it may give you no support for things that you do need to do. Sometime later in the semester, I have a very pointed opinion about Node.js that falls into this category, but I will do that later because I need a couple of beers before I'll say that. OK, so let's talk about Rails as an example of a model view controller framework. So here's the stack that we saw sort of a couple of lectures ago about generically what are the components in most software as a service applications, right? In terms of the building blocks, there is a database or some other place where stuff can be stored. There's a place where the app code actually runs, and we said that typically that is in a container that we call the app server. There is the HTTP server, which manages HTTP traffic to and from the outside world, and all of that is what is communicated with by the client, which could be a browser, it could be an API client, it could be curl, etc. So inside the box that is your app, here's what a Rails app gives you. We're actually going to do a little exercise later in lecture where we're going to create a brand new Rails app from scratch. And it is so opinionated about the idea that the 3 things in your app are models, views, and controllers that it actually creates directories for each of them. So there's a directory in your app called controllers, and everything in that directory is expected to be a controller. There's also a whole subsystem called routing, which maps URIs to routes. And yeah, Sinatra sort of does that, but you'll see a reason why the Rails routing system is way more powerful and gives you the ability to do a lot of much more sophisticated things with very little work. There's also a directory that it creates called models. The assumption is everything in that directory will be a model. And in the case of Rails, that means a very specific thing. Most Rails models are designed to work in a particular way with a relational database. The way that they work with that relational database is called active record, and that's one of the most important parts of Rails, which if we don't get to today, we certainly shall on Tuesday. So it's not too much of a stretch to say that the model part of model view controller in Rails is instantiated by the design pattern called active record. And finally, there was also a subdirectory called views. And inside that subdirectory are other subdirectories for every model so that every model can maintain its own set of views. Rails is also pretty versatile about how you can create those views. It has different preprocessors. We already saw herb, which lets you embed Ruby code into an HTML file or anything else you want. There are other preprocessors as well. Rails is agnostic about them. But for the most part, you'll probably be creating either JSON data structures or views very much like the one that we saw in our simple Sinatra application. Everything in the models database is a subclass of active record base, which is the functionality the Rails framework gives you to connect your model to the database in a nice way. Everything in the view subdirectory are subclasses of action view, which again gives you certain behaviors for making view rendering easier. For example, last lecture or previous, someone asked, can you build up a view by having sort of reusable chunks and then put those chunks into different views? You can absolutely do that, and that's an example of the kind of thing that action view gives you, a collection of behaviors that make it easier to sort of assemble views. And application controller, as you might expect, what kinds of things would the controller do? Well, it helps with parsing URLs, it helps with parsing parameters and the kinds of stuff that we already saw in the Sinatra example. It can help with things like managing cookies. So the responsibilities are nicely divided among these three things. So let us talk about what that is. So the problem this is trying to solve is when we think of a model, like a movie model, which we've been talking about ad nauseum, we say that that is record-oriented structured data. What we mean by record-oriented is that every movie has the same structure as every other movie. It has a title, it has a rating, it has a release date, and so on. The specific values of those properties are different, but in some sense, they all follow kind of the same template. So if you think of one movie as sort of a record, then record-oriented data just means we have a whole bunch of movies. The structure of every record in that collection is the same, but the attributes of every record are going to be different. So the key question that we have to answer is, in our case, is we need a way to store that stuff so that it has a permanent home. We also manipulate those things in the programming language. So when you create an instance of an object in Python or Ruby or any language, that instance of an object has some in-memory representation. Usually, as a programmer, you can be blissfully ignorant of what it is. But somewhere down at the level of bytes, that data is being represented somehow in the interpreter so you can manipulate it and pass it around. Now we're talking about having that data stored somewhere like a database so that we can retrieve it later long after the interpreter has forgotten about it, right? Because one of the things, if you remember when we were doing our simple Sinatra app, is every time a new request hits the app is like waking up for the first time in its entire life. It doesn't know anything. So if we're going to store the data permanently, it has to live somewhere outside of the programming language itself, which raises the problem of how do you represent it, and how do you sort of go back and forth between how it looks when it's stored somewhere permanently and how it looks when it's in memory being manipulated as an object. Okay, so on our grand tour, here's where we are. We just came from controllers. We're now over to models. So how do you represent a persisted object when you're about to store it? In memory, we have these objects that if you ever try to print out the representation of one, Ruby will say something like, this is some whatever instance of the movie object. You know, it has these different properties like names and ratings. And wow, that's not what it looks like on my screen at all. Let's see if I can. There, that's what it looks like on my screen. So we have an object in memory. We're talking about somehow serializing, creating an external representation of that object that we can store someplace, so that later on we can read out that external representation and convert it back into something that can be manipulated in the programming language. Right? Not necessarily a trivial thing to do. So in the case of a movie with name and rating attributes, who knows how that's represented in memory, but we need some way to represent it deterministically outside of memory, somewhere like an external database. In the case of Rails, it has made the opinionated decision that this shall be done using a relational database. This is not the only way to do it. You could put things in files. You can use a NoSQL database. But for a variety of reasons, relational databases are unusually powerful ways to do resource-oriented apps. And that is the way that Rails has chosen. Again, if that's not your cup of tea, you probably want to use a different framework, because so much of who Rails is about doing it this way that you'll find yourself kind of struggling in pain against it. If you have never seen a relational database, you don't have to worry. I will give you a very, very quick overview of how they work today. And I have found pointers to 2 really excellent mini courses that you can do in like a half hour that give you a great introduction to relational databases in SQL. But the basic idea is quite simple. Each type of model, so each type of resource in your app, gets its own table in the database. The table is allowed to define whatever columns it wants, because every row in the table is going to have the same columns. And the columns are where you store the attribute values for different instances of the model. So every movie gets its own row. Every movie has a release date, has a title, has a rating, and it has a unique ID, which doesn't mean anything to the movie, but it's the way that we pass it around as a resource. It's the unique name that we use to identify that resource for all time. Most relational databases support what I'll call basic scalar types. When I say scalar types, what do I mean by a scalar type? What would be an anti-example? What is a thing that is not a scalar type? Say again? An object, true, because an object has a thing that's a bunch of fields. So you can think of a scalar type as being one little thing, like a primitive type, like an integer, a string. Most databases have a special representation for dates and times. But for example, array is not a scalar type, right? You cannot have a column in the database whose value is an array of things. Well, you can, but for a variety of reasons, it works extremely poorly if you try to do it. Okay, so in general, you have to find a representation for your models where any given model attribute is something that is a basic scalar type. And each row has a unique primary key. That's this thing on the left. This is guaranteed to be unique within that table. So no other movie will have an ID of 2. No other movie will have an ID of 11. In the database world, you can give this column any name you want. However, in Rails's opinionated world, this column always should be called ID, just ID. Again, why? Because there's a whole bunch of automatic machinery that if you agree to do this, then there's a lot of work that you don't have to do. A lot of things that just work because they're allowed to assume that you followed the convention. Okay? So this is sort of a very simple example of what a table might look like for storing the movies we've been talking about. And if you haven't heard the term schema, it generally means the collection of all the tables associated with some app. What is the structure of those tables, and what are the relationships among those tables? So if you have never seen SQL, which some people call SQL, but technically it's SQL, SQL is a language that was devised for manipulating data that is stored in just these databases. And most of the time, if you're writing a Rails app, you will rarely, if ever, have to manipulate SQL directly. So if that's true, why am I about to show you some simple SQL, and why have I recommended a mini course that gives you like a 15-minute intro to SQL? Because if you're absolutely clueless about SQL and something doesn't work the way you expect in your app, you're going to hit a brick wall debugging it, right? This is kind of one of the realities of dealing with complicated software, is you need to know a little about a lot of things. You don't have to be a SQL expert to use Rails, but if you know absolutely zero about SQL, you're going to run into problems that you have no idea how to solve. You don't have to be an expert in doing front-end layout and CSS, but you have to know that CSS is a thing, and that if you have the same CSS ID on multiple elements, that's an error, right? So you have to know just enough to avoid getting yourself into deep, deep trouble. And that's kind of my theme for this class. There are so many things, so many technologies that touch web apps, that the best we can hope to do is make you aware of each of them enough that you don't paint yourself into a corner, and sort of that you know what you don't know. So as you might imagine, SQL allows us to do the basic operations on a table row. It actually allows us to do a lot more. But the basic operations on a table row are represented with statements like insert into for create, select from, which is a way of picking records that match certain criteria, update records, meaning if a record has a certain criterion, modify it so that its attributes take on some other values, or destroy records. Again, you do not need to copy all this down. In fact, most of the time, you will not ever have to deal with it directly. But when you see it in the log of your application, I want you to recognize what's going on, and so you'll know where to go for help. Okay, that is the most basic possible thing. And you don't have to do it because all of the machinery that Rails provides for working with models creates the queries for you. You will basically specify, I would like to retrieve, let's say, movies that match the following criteria. Or for the following specific movie, I would like to update certain of its attributes to have the following new values. And Rails will generate the correct SQL statements to do that for you, so that most of the time you never have to see them yourself. By the way, the relational algebra, as it's called, which is the formalism for representing and manipulating data that is stored in this way, is sufficiently impactful that Ted Codd, who is considered the inventor of it, won the Turing Award for his work. So it's good to acknowledge our elders and those who have laid the foundations that we can put our apps on top of. So that's what SQL looks like. Do not worry about trying to parse and understand this mentally. I want you to just realize that this is how it works. What I would like to show you, if my live coding chops hold up, is I will show you actually interacting with a model and how you actually never have to see this. So let's see if this works. What does a model look like in Ruby? First of all, it is a subclass of a thing called active record base. What is active record? Active record is the name of a design pattern, design strategy, according to which the objects that you represent in your programming language, like movies with attributes, can be mapped to a database structure where the table has particular columns, and the columns somehow are made to correspond to those attributes. In other words, active record is what people would call an object relational mapper, because it takes a thing that is an object, a movie in Ruby, and it takes a thing that is a relational engine, like a database, and it finds a way to map the representation of that object back and forth to the relational setting, which is what I'm going to show you in my live coding. We can think of it as it connects your model to the database, and it provides basic operations on the model. Actually, it provides even very advanced operations on the model. Thanks to convention over configuration, we know how the database table is named. Basically, you take the name of the model, and you assume that the database table is lowercase and pluralized, which kind of makes sense, right? If a movie is a thing, then movies would be a table that has a lot of them. And the cool thing is that the column names in the database are the getters and setters for model attributes. And this is the part where you appreciate why Ruby and Rails sort of walk around together a lot. So let me show you what I mean by that. OK, so what's in my Rails app? When we said a trip through a typical Rails app, well, the application, there's that directory, a whole bunch of other stuff we don't care about right now, config, which is where the routes file is. I haven't put anything in the routes file, but I actually don't need it for what I'm about to show you. If we go inside the app directory, we see models, views, and controllers. We also see some other stuff, but focus for the moment on models, views, and controllers. And inside the models subdirectory, I have placed a single file called movie.rb. Here is that file, movie.rb. You'll notice that movie.rb does not appear to actually have any code in it. All it says is, I'm going to define a class called movie, which is a subclass, inherits from active record base. It turns out that just doing this gives me a lot. And it gives me a lot because I have also defined, I have set up a database table, which I will show you in the next piece of the lecture, in which a movie has, let's make this work. Please work. Yay. Let's see. Suppose I create a blank new movie. OK, well, let's see. Rails believes, or Ruby believes, that I have created an instance of the class movie. It has an ID with no value, a title with no value, a rating with no value. You get the idea. So where did all these attributes come from? How did it know that that's what a movie should consist of, given that in the movie.rb, where I define the class, I have none of that code? OK, so the answer here, which I think is particularly cool, is that it actually said, so movie.rb is a model. It inherits from active record base. That's how we know it's a model. OK, I will go into the database. I will locate a table whose name can be constructed from the name of the class, so lowercase movies. In that table, I will look at what the names of the columns are. I will use the names of the columns as my assumption about what a movie actually is. And I will define getters and setters that work on those attributes, meaning that if I now say something like that, it actually worked. And I can get it back. Notice what's happening here, because when we did our intro to Ruby in like week 1 or week 2, do you remember how we used to have to define these getters and setters? These were just methods that were wrappers around an instance variable, right? We had an instance variable, for example, at title, and the title equals setter method was just a wrapper that set the instance variable. The title getter method was just a wrapper that returns the value of the instance variable. But that is not what's happening here, right? We're still getting the attribute, but now the attribute is coming from some representation of what's going on in that database. It is no longer the case that there's a simple instance variable called m.title. And in fact, I can probably prove that. Well, I can't do it in a way that isn't confusing. But you might have to take my word for it in this case. Compared to what we did before, which was, people remember attribute accessor and things like that, where we used to have to say something like that, and that, whoa, and whoa. And that would define some methods that served as, I don't know what's happening. It would define methods that gave us access to an underlying instance variable, but we haven't had to do that here. In fact, it would be harmful to do it. Okay, so we're still getting an object. The object still has attributes. You still get to the attributes the same way as if this was a plain old Ruby object. But it isn't a plain old Ruby object. It's an object that is based on inheriting from active record base and whose attributes are defined by what the database columns are. Question, sir?
How does the database have those columns?
OK, so one question is, how did the database get that way? Like, who made that table and who had those columns? I'm about to show you that next. But it is a great question because I've just sort of said the database exists and the table has those columns. And I have not told you how it got there. But I'm about to tell you. Yeah?
Would there be a setter for the ID value?
Good question. Is there a setter for the ID value? And what would you guess the answer is?
Well,
There shouldn't be. Because?
the user shouldn't be setting the ID.
The user doesn't get to set the ID, right? The ID is something that is generated by the database. When you add a new row to a table, the database will assign it an ID that it knows is unique. So you can read what the ID of something is, but you generally cannot set it. Perceptive question. So let's see what happens. Let's get to this question for the moment of where did that data actually come from? And let me see if I can find. You know what? I'll just skip ahead and show you the live code. It's easier. I will find the. Uh-oh. All right, I thought I had migrations here, but I don't. That's OK. I think I might rather cover migrations next time. But the short answer to the question is changes to the database are actually scripted just like anything else. You basically write a description of what you want a table to look like. In this case, again, don't worry about trying to understand every bit of this code. I just want to make sure that the question at least gets addressed, like where did the magic database come from? I basically wrote what's called a migration, which is a way to make a change to the database schema. And my migration says, create a table called movies and put the following columns in it. A title, which is a string, rating, also a string, description of the movie, which is a longer blob of text, and release date, which is a date time. And then I ran a Ruby task that essentially causes this action to be applied to the database. So I will show details on Thursday about how this is done and why we do it this way. Because those of you who have worked with relational databases, there's usually some kind of a graphical user interface that lets you manually create new tables and add columns on tables. And a legitimate question is, why wouldn't we just do that? Why am I not up here showing you with some database GUI that I'm going to manually create this movies table? And there's a good reason for the answer, but I would like to postpone it until Thursday. Because I would like to come back to the Ruby side of a model. There. OK? So the thing I wanted you to get from my very quick live coding thing here is that we still have getters and we still have setters. But they don't simply wrap the modification or returning of instance variables like they did when we used attribute accessor. And this is a really nice example of what we mentioned when we talked about this behavior in Ruby called the uniform access principle. That when I say movie.title, I cannot tell from the outside whether movie.title is just returning an instance variable or whether movie.title is computing something and returning a computed result to me. There's no way for me to tell from the outside the implementation of how a movie title is stored. And you can see in a scenario like this why that is an interesting design feature. Because now, without any changes to sort of language semantics and how you would usually write code, I can say, I want the title of a movie not to just be an instance variable. I want it to be some value that came out of a database. That's fine. I can still say movie.title, but now movie.title is a method whose code arranges to get the proper value from the database and hand it back to me. Right? It's not just wrapping an instance variable. That was the main thing that I wanted to get out of the mini live coding demo. One thing I want to mention is that in my mini live coding demo, coming back to, hold on, I need to get back to mirroring so you can see my screen again. So I'm going to set some other things for this movie. But I have not actually saved the movie in the database yet. So in terms of the diagram I showed, where on one side we have object in the programming language, and on the other side we have a database, right now all I've been doing is I created a new object in my programming language, and I have set attribute values for that object still in my programming language. I have not actually said, OK, I want this saved to the database. One way that you know this is true is the ID of the object is nil, as it must be because it's not in the database yet. If it was in the database, it would have to have an ID. So I shall now arrange to save it in the database. Here we go. Boom. Notice what happened. Because I'm in the console and it helpfully prints out logging messages, it's showing here is the SQL query that I constructed in order to save the movie for you. Again, most of the time you do not need to read these and understand them. But if you are familiar with, oh, what's going on is SQL queries are being generated, when something doesn't work, you can start looking at the query and say, OK, what went wrong? Maybe the query wasn't constructed the way I thought. The transaction has committed, which means the thing is saved in the database. Well, if that's really true, then it should now have an ID, whereas before it did not. And it does. The ID is 1. Not surprising, because this is a brand new database with nothing in it. This is the very first thing I'm putting into that table. Most databases make a habit of just giving out IDs in numerical order. What else can I do? Well, I can go find it. In fact, just so you know I'm nothing up my sleeves, I will quit out of the app, and I will restart it. So I'm back in the app, and not surprisingly, if I try to look at the variable m, undefined, right? Because I quit the app. This is a brand new environment, brand new app. It knows nothing about anything. However, I can still say, let's go find it, where the ID is 1. Ta-da, I have it back. Oops, I thought I had it back. Oh, sorry, it's what I said movie, right? Yeah, movie dot. I hate when things work against me. Oh. That's what I meant. In this case, my criterion for finding a movie is one where the ID is 1. Methods like where always return a collection that matches. In the case of ID, there can only ever be at most one match, but it always returns a collection. So this would return a collection of one thing. So I had to pick out the first element of the collection. Notwithstanding that, the message is the movie came back, right? I got it. You know what? Let me start again. Just so that there's a clean edit somewhere when you're watching the video. I will now find the first movie matching that criteria. And there it is. And yes, indeed, the title is what I expect, and the rating is what I expect. I never specified a release date, so that doesn't have a value. But notice what's happened, right? Previously, I fired up the app. I created an object in Ruby. I saved that object to the database. I quit entirely out of Ruby so it forgets everything it ever knew. And I have restarted it, and there is the object, freeze-dried and ready for my consumption. That is the essence of SaaS apps storing data. There has to be some agreement on what you do to make that data formatted in a way that can be stored somewhere so that when you reconstitute it back into the language, it looks just the same as when you stored it. And that's the thing that Active Record buys you. It essentially automates all of that concern. Yes, sir?
So this
Right, so Rails is just a big library. And so the question was the save bang method that in fact, let's make a change. Let's change the rating to something else and save it again. And the question was, where does that save bang method come from? I shall use the Socratic method to get all of us to the answer. If I'm calling save bang on movie, that implies that I expect movie to be a thing that responds to the method. What class of thing is movie? Here's a hint. So movie is an instance of, it's an instance of the movie class. The movie class inherits from active record base. I have not defined any save bang method in movie.rb. However, as we know from object-oriented programming, if you call a method on an object and it's not defined in that object's class, it will next try the superclass, right, the ancestor class. So in this case, save bang is defined in the active record library. And there's a whole bunch of other methods we're going to see that are defined there as well. So that's why I'm saying that just by subclassing from active record base, you get all of this machine. I haven't written a line of code yet that says anything about how to deal with movies or what they are. But the fact that movies know how to store themselves in the database and reconstitute themselves later, and what the attributes are just by looking at the database table's current structure, all of that is what I get for free from the active record relational mapper. Yes, sir?
So like you have like a movie.new, I guess like that's where you initialize it. How does it know like what fields are in?
How does it know?
What fields are in?
So the question is when I create, let's create another brand new movie. And I think the question is, when I created this new movie object, how did it know what the field names were supposed to be? Is that the question? Yeah. Because it basically went to the database, it found a table for all the movies, and it just looks at the column names. Okay, well, the column, I don't have a GUI of the database ready to show you, but if I did, I would show you that the database columns have these exact names: ID, title, rating, description, release date.
The table has to exist first.
The table, yes. Okay, good point. When I say movie.new, actually, we could do the counterexample. I'm going to destructively, well, I'll move it out of the way. Hold on. So what happens if the database does not already exist? Let's do that. So I'm going to destructively move my database. I'm going to get it out of the way. And I'm going to create a blank new empty database. So again, don't worry about what is he doing with these file names. I do not understand them. It's fine. Don't worry about it. I will tell you that what I'm doing is that I just moved, I got out of the way the database that I had been using for that live coding example. And I've temporarily replaced it with a blank, fresh database that has no tables of any kind in it. And now, what happens if I once again try to go into Rails console and do the thing I did before? Well, if I now say movie new, what is the nature of the error message I should expect to get? What is it along the lines of? Not defined, and why would it not be defined? Why is it going to have trouble creating, like figuring out what the correct attributes are for a movie object?
The movie database doesn't exist.
There's no table of movies in the database. And indeed, if we go up through the spew of error message, it could not be more clear. It could not find table movies, right? So why is that important? Because it knows enough. By the way, is the movie class undefined? No, the movie class is absolutely defined. The problem is exactly that the movie class, hold on a second. The problem is exactly that the movie class says that it inherits from active record base, which means it expects the attributes of a new movie to be defined by the columns of the movies table. And yet, when it goes to look for the movies table, there's a database, but there isn't a table in the database whose name is movies. Therefore, it has no way to figure out what kind of a model movie should be and what attribute values it ought to be allowed to have. Right? So that's what's going on here. This is a way to take a plain old Ruby object and connect it to a relational database. We also talked about ways to pull things out of the database. I'm going to sort of do an app walkthrough here in a minute. But we saw some simple examples of a class method called where. And remember, it's a class method of whichever class your model is that inherits from active record base. Essentially, in terms of SQL, it is building the equivalent of a select statement. It is specifying some criteria, and you're going to retrieve a collection of records from a particular database table that match those criteria. What kind of a thing do you suspect that where might return? What sort of a data structure might it return? A collection of some kind. That's reasonable. I prefer to say it returns an enumerable, because that's sort of the Ruby way of saying it returns a thing that you can treat as a sequential ordered collection. Now, whether that thing is implemented as an array or implemented as some other data structure, all that matters is that it's in order, and you can ask it for elements of itself in order. So for example, I might have a simple query like all the movies where the rating column has the exact value PG. I could also specify conjunctions. I can say that the date is less than something and the rating equals something, and then I have a hash providing values that are going to be filled in for that. Now, if you have not worked with SQL, cool, do not worry about it. Those of you who have worked with SQL might recognize that what we're actually doing is we're building up the logical constraints, but we're not actually putting together the string that SQL will execute itself. And as we'll see later in the course, one of the wonderful reasons to do this, well, there's actually at least two. One is that different types of backend databases sometimes have minor syntactic differences in how they handle SQL, but specifying your statements this way will make sure that Rails generates the compatible thing. The second and more important reason has to do with why this is a bad idea. Sorry about the blue sand there. This is like the third time this happened. The more important reason is why this is a bad idea. Is there anybody who has done sort of bare bones SQL programming and would like to say why this is an awful idea and I will fail you in this course if I find it in your project? I won't actually do that, but it's bad. What's your answer? There's a kind of attack called SQL injection where a malicious person could fill out a web form knowing somehow that the contents of some field on that form are going to be substituted in here. And they could cause this to build a very destructive SQL statement that like deletes tables and does all kinds of bad stuff. I have a great internet meme about this that I'll show you when the time comes. But the bottom line is Rails provides all of these facilities. In fact, I'm just going to come out and say this. If you can do it in SQL, you can do it in Active Record. And in fact, you can probably do it better in Active Record because it will usually generate a better query than what you would generate yourself. These queries are really simple because we're just looking at like one or two fields. But when we start talking later about multiple tables and foreign keys, and you have queries that can touch multiple tables and are quite complex, you will be, I think, in awe at what you can do with Active Record. And there's also this very, very simple method, which you very rarely see, which just says, this is the primary key, the ID. Just find the one that has that exact ID, which is usually not used because if that ID happens not to exist, then you get an exception, like a hard error. So most of the time, what would be a way to do this without causing an exception? If I tell you that, in general, any of these that, if you try to do this where and it turns out that nothing matches, what you will get back is an empty collection, but it's still a collection. Anybody care to speculate how you might do, if you want to find something knowing only its ID, but in a way that is safe? What might you do?
Movie.where ID is equal.
Yeah, exactly. So movie.where ID and some value. And then, worst case, if it doesn't exist, you'll just get back an empty collection, and you can detect that fact and do something about it, right? But be careful of exceptions. The other cool thing about this, as you will also see, is that you can chain them together. For example, you can say movie where rating is something, G, and here's the dot because we're going to continue our expression, and where the release date is less than something, and ordered by title. Databases are really good at returning things in particular orders and stuff like that. So this is actually all one long chain of function calls that in the end will produce a single SQL query. In fact, as a sneak preview of what's coming up later in the course, if you actually inspect the result of just calling any one of these, it is actually not a collection. It is an object that if you force it to be evaluated later, will try to generate the collection for you, which is really, really, really cool. It's lazy evaluation. But that's a preview for next time. What you care about for this time is that every one of these things, the thing it returns is actually an enumerable relation. And that relation can be chained with other relations to provide more and more constraints. And at the end of the day, one query gets done. Okay? This Active Record does a pile of stuff. And I'm probably 2 to 3 hours away from finishing an optional active record calisthenics things that I'm going to invite all of you to try. It is not a mandatory homework. There's already the homework where you're sort of walking through an existing Rails app that uses these constructs. But kind of like the Rails routing practice app, I'm putting it out there so that you can, on your own, sort of cut your teeth a little bit better and feel like you get comfortable with the basics of active record. So I'm hoping to be able to post that by like tomorrow morning once I've sort of debugged it. OK, so that was read. We haven't looked at update or delete. But supposing that we have an instance of a movie, we can modify its attributes and save it again. We saw that before. We can also update its attributes in place. So there's another active record call, update attributes, where we just pass a hash. The attributes that are named in the hash will get replaced with the corresponding values, and that happens immediately. So update attributes doesn't require a subsequent save. It operates directly on the database representation, kind of like create. Right? One of the examples I did last time is that new and create both take a hash of values, but new does not actually save the thing to the database. Create tries to. Okay? So again, you will get a chance to play with all of these, but I'm trying to give you an overview of the landscape. And as you might expect, all of these are transactional. So if you specify some complicated combination of things to update and it fails, then either all of the updates happen successfully or nothing at all happened and it's just like you had never tried to do it. That is one of the big benefits that relational databases have always given us, which is atomicity. And as you might expect, active record preserves all that. So if you have an update attributes query where where a number of attributes are trying to be updated, but one of them has an illegal value, you can safely assume, if it fails, that none of the attributes were updated, and so on. Question?
Sorry, so is that update attributes call, is that changing the release date of all movies whose rating is PG?
Ah, good question. For which movie or movies is this update attributes updating the rating and the release date?
Oh.
Would you like to answer the question?
I feel like it's M, right?
It could be M because that's the receiver of the call, right? No, it's fine. It's a reasonable question. In fact, same thing as up here. When we have an individual instance of something, we can talk about changing an attribute on it. We can talk about saving it. In fact, we can also talk about destroying it. But just as a reminder, the where call has to operate at the class level, right? Because there isn't a specific movie on which we're calling where. We're calling it on the movie resource in general, like the entire database table. So things like where and new and create, it should make sense why those have to be class methods, whereas things like update attributes, save, and so forth are instance methods because we already have the specific item or items to which we want them to apply. Excellent question. And finally, delete, which is maybe surprisingly or maybe not, is an instance method. I have a thing, and I'm telling it to destroy itself. A reason that it turns out you want to do this is because, as you'll see, you can specify preconditions on, like, before you delete a movie, do some other things that make sure, for example, that no other existing reviews try to reference that movie. Those are called callbacks, and we'll deal with them later. But calling destroy gives Rails a chance to clean up after the object before actually blasting it out of the database. Question?
You said that, like, if you want to do a bunch of updates and one fails, they all fail. Does that mean it checks every single update first before it actually pushes the database? Or does it, like, change everything up until it fails and then change everything back?
So the question is, given my claim that if you're trying to do some complex updates and anything during that process fails, and the result is that it is reverted back to the way it was before, how does that actually work? Is it that some of the updates are happening, but if something fails, then all of the ones that happened get rolled back? Or is there some checking process so that before it actually tries to do them, it kind of makes sure that they're all going to work? The short answer is that it's actually inside the database logic. So it's really the database that gives us the property. It's not Rails that gives us this property. Rails is just freeloading on this property. The question as to how it's done internally in the database is an excellent topic about which CS186 has a lot to say. We probably won't have time to go into much detail in this course, but the short version of the answer from a programmer's point of view is, regardless of how it's implemented in the database, the externally visible state from the programmer's point of view is either all success or all failure. So internally, the database may be partially doing the updates, hitting a stumbling block and saying, oh, I got to roll everything back. But you, as the user of that database, you never see that intermediate state. The only states you see are the state before everything happened and the state after everything either succeeded or it looks like it just all failed. It is a wonderful, wonderful thing, and we'd be dead in the water without transactions. OK? All right. So let's summarize kind of where we are so far with this. And again, this is like 1% of 10% of active record. But I just want to get you off the ground to the point where you can do the homework. And if you want, the optional active record practice exercises I will publish tomorrow. We've seen new, which creates a blank in-memory only model instance that has not yet been saved to the database. We've seen save, which you can call on a model instance, which means save this one to the database. And if that model instance was just created with new, then that's like a SQL insert. It's adding a record to an existing table. But if it was an existing model instance, it just updates the one in place that was already in that table. We've seen create, which is just new and save mashed into a single call. We've seen where, which allows you to extract records from a table matching certain criteria. I haven't shown it, but there's also one called all, which does the brute force thing that you'd expect. It gives you back all of the records in that table, except it doesn't. It gives you something that it'll evaluate later, but leave that aside. We've seen update attributes, which updates things in place, and destroy, which essentially blows something away after doing any housekeeping cleanup to make sure nothing depends on it anymore. So those are the basic CRUD plus index operations, and how active record in its sort of most basic form gives you a nice abstraction around them. Again, if you have worked with databases before, it may seem like, why should I learn to use this collection of different methods when I can write my own sort of simple SQL queries by hand? And the answer I'm going to give is the same one that I gave for things like routes. Once your queries start getting more complicated, because they start affecting multiple models in different tables that have relationships to each other, this way of doing it will save a lot of grief and pain and produce queries much nicer than most of us probably could write for ourselves. So it's, trust the process, have some faith, 1,000 points of light. That's a George H.W. Bush reference, but that's OK. So we haven't yet talked about all this stuff in the database and how it got there. So let's spend a few minutes talking about that. And one of the things that when I started working with Rails I thought was a great design decision is that it provides a way to distinguish between the database that is out there in the world under your app that your customers are really using and the data that you're using when you're developing new features or testing new stuff out. So your customer data, as you'll quickly find out during your projects, is golden. And when you're hacking your app and trying to sort of manage new features, you want to make sure that you're not accidentally modifying your customer data in bad ways. Also, when you have to change the schema of your database, right? You have to add a table for a new model, or you want to add some new attributes onto an existing model. You would like to be able to do that in a disciplined way. I mean, if you're working in a team on a code base, you would absolutely not think, or at least I hope that you would absolutely not think, of having your team sort of just save files with no version control. Let's not use Git, let's not commit stuff, just everybody change what files whenever you feel like it. Everybody has their own copy of the code base, but if you're changing files, we'll just merge the results later, right? My hope is that that's not the way you think about managing code, and it's not the way you should think about managing the database either. So the answer to both of these is how do we automate and how do we keep track of the changes that we make to the database? And as far as keeping your customer data golden, Rails has what I think is a lovely solution, which is that the framework has a notion of 3 different environments. There's the production environment, which is what's actually running on a real server that people are using. There's the development environment, which is each individual member of the team. This is what is deployed on their computer when they're writing new code. And there's the test environment, which is only used for running automated tests and is regenerated from scratch every time you do a new test run. Each one of those 3 environments can have its own database. And that's really, really, really useful. Because when you're developing, you just point the development environment at a different database that is not the production database. And now you're in no danger of changing any of your data. Now, the downside of having 3 databases is the schema has to be consistent across all 3 of them. So when it's time to change the schema, you actually do it by creating basically a little script describing what changes you want to make. That script is called a migration or a database migration. And as you might expect, Rails has all kinds of machinery so that you don't have to worry about which specific brand of database you're using. The syntax for migrations will do the right thing for all of them. And now, once you've made a schema change, let's say in your development environment, you've developed new features, you know that the new schema change works, we're good. Now you just take that same script, which you already wrote, And now you point it at the production database, and there's no way you can make a mistake because it's the same script. You made the change programmatically instead of trying to do it multiple different times by hand. So why would you do this? First of all, you can track when the database was changed. Who made this change to the database and why? Because each change now is basically a little code file that you can version. Because it's automated, it's repeatable. So whatever you did on one database, by just running the same script again, that exact same set of actions happens on the other databases. And this is a theme that I've talked about doing before, like do as little by hand as you possibly can. Deploying your app, changing your database, anything like that should be like one command line and it's all done automatically because that lessens the likelihood that you can screw it up. Or if you do screw it up, at least you'll screw it up systematically. You'll screw it up the same way on every copy. So when you figure out how to recover from it, you can apply the same recovery to every copy. So we're going to specify what to do and have tools that allow the automation to sort of handle it for us. And in the case of migrations, one of these tools is a code generator. So I will do a live demo of this in a moment, but let me explain what I'm going to do in the demo. This is one of the sort of utilities that comes bundled with Rails. And if I say Rails generate migration and I give it a name, so I'm going to create a migration that adds the movies table to my database. Because we're starting out with a brand new clean app. I haven't done anything yet. My database is not set up. So I got to put something in there. And this command will generate basically a skeleton file, kind of like the kind where it says your code here and there's starter code around it. It's that. Then I fill in my code, which is a description of the table I actually wish to make. And then I apply the migration by saying, OK, here's a description of some changes to make to a database. There's my database over there. Go. All right, so that's what I'm going to do. So I will type the exact command that I just said, which is Rails generate migration. I'm going to call it create movies, because my intention is to have a migration that creates the movies table. OK, success. Green is good. That's a thing that you can learn from a lot of Rails tools. When it prints out something in green, you should rejoice. Green is good. Red is bad. OK, so what did it do? It created, it says, a file with this name. So let us take a look at that file. And I use Emacs, and I don't want to hear about it. I actually put all of my Emacs files under version control just a couple of days ago. I've been curating those files for 35 years, ladies and gentlemen. There's a lot of cruft in there. So it said it created a file called, there's where we are, rotten potatoes, db. OK, so it said db/migrate. There's migrate. And here's the file that it said it created. So what's in that file? Yes, this one. Sorry, out of date Dira. There we go. OK, so this file is what was created for me. OK, this is the starter code that Rails generated so that I could create my movies table. Now look at that. One of the things it put in there is create table movies. How did it know that I wanted a table called movies? I mean, I didn't really tell it that explicitly. All I said was generate migration, and then I gave a name afterward. But the name I gave was create movies. So a reasonable guess by the migration generator is, oh, maybe you wish to create a table called movies. And if that was not what I wanted, I can just change this. But Rails tries very hard to figure out what you want if you use standard terminology like create. So I'm going to put some code in here. This is the your code here part. Anybody remember from 61A? OK, let's do that. Fortunately for you, though, I prepared some code in advance that I can cut and paste. Whoops. So that things go a little bit faster. And auto indent, there we go. So, and I actually have a redundant line there. All right. So what does my migration do? Without worrying about the syntax in detail, getting the gist of what's going on, it looks like I'm going to create a table called movies. And I'm going to say that the columns of that table should be title, which is a string, rating, which is also a string, description of the movie, which is text. That's kind of like a very long string, and release date, which is a date time. Most databases have a special way of storing fields that have to do with dates and times, because databases can do basic arithmetic on dates, like records where a certain date is less than. Although we won't cover it in this lecture, the timestamps is basically adding 2 additional fields to my movies table that Rails will automatically update. So there's a timestamp called created at, and whenever I create a new record in that table, Rails will automatically fill in the date and time that it was created. And whenever I make a change to an existing record, Rails will automatically keep track of the last time that that record was modified. And I don't have to do anything to make that happen. I just have to make sure that the correct columns are in there, and timestamps puts them in. So this is a migration that creates a very simple table called movies. And movies have these 4 attributes, plus the timestamps, which we won't worry about too much today. Now that I have that migration, let us first verify that without applying the migration, I will not have a successful app. If I try to open my Rails console, which, if you remember from last time, this is just like IRB, like the interactive Ruby interpreter, but it loads my entire Rails app. So I can interact with my app, and all of the classes and stuff defined in my app are defined on the command line here. If I try to create a new movie, I get pain because, there it is, could not find table movies. Why is that the error I got? Because it is already the case in my app that I've said that movie should subclass active record base. To Rails, that means, great, there ought to be a database table called movies. I'm going to go find it. But no such table was found, hence this error. Now we will take the migration that I just created, and we will apply it. Rake db migrate, which basically says, look for any migrations that have not yet been applied, and apply them. And look, it worked. Migrating, it created the table, blah, 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 all done. No errors. And if I go back into Rails console, I can now confirm that if I try to do something like movie.new, now it works. Why? Because I added the table that matches the name movie, and Rails was able to go into that table, find the names of the columns, which I declared in my migration, and say, OK, now I know what a movie object should look like. Here's your blank template of a movie object that you asked for. OK, so what did I do? What did I do? I did Rails generate migration, which gave me starter code. I filled in some text that actually describes the changes I want to make to the table. I did bundle exec rake db migrate to apply the migration. So that means take the stuff in my migration file and actually make those changes against a particular database. In this case, it's my development database. Because Rails is smart enough to know that when I'm sort of working with my app and typing things into the command line, I'm in development mode. But there are other ways that you can basically tell it, apply it to the production database, apply it to the test database. We will get to those things in due time. By the way, if you start seeing bundle exec everywhere and you begin wondering why you often have to prefix Rails commands with bundle exec, it's a little weird, but let me explain the reason. Remember when we talked about gems and gem files and making sure that the correct versions of all libraries are bundled with the app? Bundle exec basically sets up the environment of your command line so that the correct versions of all those gems are loaded before these commands are run. So for example, rake is itself a gem, and to make sure that the correct version of rake is being used, it actually would look in your gem file and make sure that that's the version that it's set up to use. So you will get used to seeing bundle exec in front of commands typed at your terminal, because it's basically a way of making sure that not only when your app is running are the correct libraries in place, but when you're doing utility commands like making migrations and stuff like that, that again, the right versions of all the libraries are the ones in effect when you run that command. That's bundle exec. You'll see it all over the place. What if we wanted to apply the migration in our production environment? Well, if we are running our apps on Heroku, which we will be for the remainder of the class, Heroku has their own command line thing that by now most of you have downloaded. And you could say Heroku run, which will take the rest of the command line and arrange to run it in your app's environment on Heroku. In that case, we don't need bundle exec because Heroku actually takes care of doing what bundle exec would have done. Okay? But the important thing is that these are two different databases. How do we know? Well, for one thing, in the app, we can look in this config directory, and there's a file. Oops, I'm sorry, you can't see it because I'm not mirrored. Let me turn the mirroring on again. This is a file in the config subdirectory of every Rails app. It is automatically generated with some defaults, but you can change it. But the important thing to notice about it is that there are 3 different environments here: development, test, and production. The way this file comes out of the box, all 3 environments are set to use different SQLite databases. But in practice, the production database is probably going to be whatever you use on Heroku. And in fact, for Heroku, it doesn't matter what you put here because Heroku will override it anyway on the Heroku side. Right? But from Rails' point of view, these three environments can have three completely different databases. And in fact, in this example file, you can see that they do. They're just three different SQLite databases, which are sort of the sort of baby version of a SQL database, but they are three different files. Okay, so what have we learned? There we go. And by the way, when I said when you run dbmigrate, Rails will check to see if any outstanding migrations have not yet been applied, how would it actually know which ones have been applied and which ones haven't? If we went in to look at the database now, which I shan't do because lack of time, you would see that Rails actually creates another table on its own that tracks which migrations have been applied. So if you've got a bunch of migrations that you have added, and you've got colleagues that have added other migrations, and now you merge your code bases, when everybody runs dbmigrate, all of the remaining ones will be applied. It's basically smart about knowing which migrations are still outstanding, which is great when you're trying to keep production the same as development. So we could sort of wrap this up into like what I'm going to call cookery, which is to add stuff to an app, because Rails is a model view controller, means that you're going to be adding or modifying those components. And starting with models, which is what we've been talking about for the past half hour, whether you want to add a new model or whether you want to make a change to the attributes, let's say, of an existing model, first of all, you create a migration that describes what those changes are, or if it's a new model, that describes what attributes you want it to have. You fill in your code in the migration file that got created for you. Then you apply the migration to your development environment. If it's a new model, you'll have to create a model file that specifies that the model descends from active record base. That will connect it to the table you just created. When we talk about testing, you will see that obviously the tests want to run against a database that has the same structure as your app. So there's another command that will say, the new database schema, copy it over to the testing environment as well. But we don't need to worry about that for a while. And eventually, when you're ready to do those same changes in your production database, you apply the migration again, but now you're pointing it at the production database. Okay, so this is kind of a recipe, steps that you'll do over and over again when you're adding a new model or modifying an existing model in your deployed apps.